Oh, hello. I didn't see you there. Welcome to another video for this week. Hope everyone's doing well. Quick reminder before we get started, you should have out your notebook and a pencil or a pen or a something to take notes. And what are we taking notes on, you might ask? Well, we're taking notes on distribution. Wait, didn't we already do that this week? Well, we did. But today we're looking at distribution not of multiplication over addition and subtraction, but actually of division over addition and subtraction. This is maybe something that you're not super familiar with, so feel free to ask questions and try to, you know, uh, be communicative with us about what's going on. Let's look at what we mean when we say distribution of division over addition and subtraction. Well, there we go. That's an example of an expression that would be simplified using distribution of division over addition or subtraction. Now, it's a little confusing because like we don't see the division symbol anywhere in this expression. We maybe would think of it more like this, right? Where we would have this kind of traditional division symbol. At this level of mathematics, we kind of never ever use that symbol. Like we only really use it in the steps of operations to show you division. We really think of this bar right here, this fraction bar, as division. So when you see the fraction bar, you can think to yourself, oh, I'm doing division, and maybe you'll be doing distribution. Now, how would we simplify 35 minus 15 quantity divided by 10? Well, it's a lot like how we simplified distribution with multiplication, right? The idea is that everything here is being divided by 10, so we can instead divide the pieces by 10 themselves. Let's look at what this looks like. So we would have 35 minus 15 divided by 10, right? Again, reminder, we have this division bar here. So really, we're kind of dividing both of these two terms by 10. Notice I'm putting in those little arrows, kind of the same way that we did when we did distribution with multiplication. So our next step would look like that. Each individual term is being divided by 10. Now, if you're not sure what 35 divided by 10 is, or 15 divided by 10, that's fine. You can get out your calculator, bleep, blurp, bloop. Turns out that this would be 3.5 and 1.5. And 3.5 divided by 1, or subtracting 1.5 is 2. But you say, what if it's not correct? Well, in case it's not correct, we're going to simplify it another way, just like last time, using these steps of operations. So here, as a reminder, is the steps of operations. We have our addition and subtraction as the bottom step, multiplication and division. See, there's that symbol, but like, as our middle step, and then powers and roots as our top step. And when we simplify, we work our way down the steps. And everything within parentheses is kind of like its own little miniature world of the steps of operations. So let's look at our expression again. We have 35 minus 15 divided by 10. The 35 minus 15 is in parentheses. So instead of distributing, we're just going to simplify everything we see here inside these parentheses. That gives us 20 over 10, right? Because 35 minus 15 is 20. Hey, that's not too bad. And now we only have a single term here. So we're not going to actually be distributing this 10. We're just dividing 20 by 10, which gives us 2, which is exactly what we got over here, right? Same thing. Boom. We saw last time that that is a really good thing in math when you can simplify something two different ways or solve something two different ways and get the same thing both ways. It's a great way to check yourself. And that's it. There are going to be some practice problems like what you did last time. You're doing both ways to simplify this. Yeah, at the end of it, you can be happy you're done and you can say, boosh. That's all I got. Bye.